back to my channel Tutelage, a guide to learner here. This is Sriparna. Hope all of you are doing well. In my last session, we had already discussed some topics under the chapter that is measures of dispersion, and that's why the previous session is called Measures of Dispersion Part 3. But today we are going to start a new session with some new topics under the same chapter, that is measures of dispersion. That's why this session is called Measures of Dispersion Part 4. Okay, so if you have missed my previous session, so please go and check my description box and my first comment where the previous session link is already shared. Okay, so learner, now move on to the next slide, and here we can see some topics, so what we will study today. So first topic is discussion on mean deviation. Second one is merits of mean deviation, demerits of mean deviation, and standard deviation and its formula. So basically, we will discuss mean deviation and standard deviation and their formula and merit and demerits of mean deviation. Okay, so learner, let's get started and move on to the main slide. So here we can see the measures of dispersion. We have already told that thing. Measures of dispersion is of two types. First one is absolute measures of dispersion and second one is relative measures of dispersion. So today we are going to discuss the first part, first type, that is absolute measures of dispersion. Okay, so move on to the next slide. So here we can see some measure uh, that under the absolute measure. So first one is range, second one is quartile deviation, mean deviation and standard deviation. We have already discussed the range and the quartile deviation in my previous session. So if you are missing, so then go and check out. Okay. So we are going to discuss the another measure, absolute measures of dispersion, that is mean deviation. So now move on to the next slide. So here this is the slide for mean deviation, and mean deviation is basically the arithmetic average of the deviation of the observed values from an average of the observed values. So observed, what is the observed values? Okay, so we consider the observed values is x1, x2 dot 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 xn. So here there are in number of values. Clear? So the deviation of the observed values from the average. So what is the average of this series? That is x bar. We are already known that x1, x2 dot dot xn. The average of that series, that is x bar, equals to summation of x1, x2 plus xn divided by total number of observation, which is n, small n. So average of these observed values, this is x bar, and deviation. Now going to the deviation of the observed values from an average. Okay, so deviation. So this is x is the observed values minus x bar, this is the average value. So deviation is what this is called the deviation. Okay, so deviation is denoted by small d. So deviation of the observed values from an average of the observed values. So x minus x bar, that means we have already told there are n number of values, and the series is x1 dot x2 x3 dot 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 xn. Okay, so the first deviation, that is x1 minus x bar comma x2 minus x bar dot 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 x in minus x bar. Clear? So deviation of the observed values from an average of these observed values. So what is the mean deviation? So mean deviation is the arithmetic average of the deviation. Okay, so we have the deviation values, that is x1 minus x bar, x2 minus x bar, dot dot xn minus x bar. Clear? So now going to the arithmetic average. So what is the calculation process of arithmetic average? That is x bar equals to summation x by n. Okay, so that means um, mean deviation, which is denoted by md, equals to arithmetic average. Okay, so summation of the x1 minus x bar, uh, x2 minus x bar, dot dot xn minus x bar. Clear? And arithmetic average, so that means this is the numerator, and which is divided, numerator is divided by the total number of the observation, and in this series the total number of observation is small n. So summation this one, which is divided by small n. Okay, so there is a space crunch, so md equals to summation of x minus x bar divided by n. Clear? So basically mean deviation is the arithmetic average of the deviation of the observed values from an average of the observed values. So the deviations are taken at the absolute number without considering the algebraic sign of the number, that is plus or minus. Okay. So we know that the sum of the deviation from the arithmetic average is always 0. It is therefore necessary to remove the algebraic sign of the deviations to find a sum, that is we take the absolute values of the deviation. So mean deviation, so we always take the absolute values of the deviation for calculating the mean deviation. Okay, so I think this is clear, and this is the basic formula of the mean deviation. And now going to the next slide. Basically mean deviation tells us how far on average all values are from the middle. So it is used to compute how far the values in a data set are from the center point, from the average. Okay, so in other words, the mean deviation is used to calculate the average of the absolute deviation of the data from the central point or the average. Okay, so many working professionals use it in daily life. So for example, teachers, when giving test to students, calculate the mean of the results to determine if the average score of the class students is high or low. So that's why mean deviation is used in daily life also. Okay, so now going to the next formula of the mean deviation. I think this is clear. Okay, so now move on to the next concept. So that is merit. We will discuss the total calculation process of the mean deviation in my next slide. Okay, so uh, for this session we have to discuss the advantage and disadvantage of the mean deviation. So at first we have to say mean deviation is very easy to understand and simple to calculate. Okay, so now going to the second point, it is rigidly defined, uh, though there is some difficulty in view of it taking only the absolute values of deviation. We have already told the deviations are taken always the absolute number without considering the algebraic sign, that means plus or minus. So that's why there is some difficulty, but otherwise it is rigidly defined or precisely defined. Okay, And now going to the third one, it is not affected by the presence of the extreme values. Basically, mean deviation is based on all variables. Okay, so not dependent on the extreme value. So there is, so that's why there is no effect. There is no effect by the presence of the extreme value. So one of the most important advantage of the mean deviation, that is, it is not affected by the presence of extreme values, which is based on all observation. Okay, so now move on to the four. So it doesn't differ from sample to sample. Okay, because it has sampling stability. Clear? So um, 1 minute. So for mean deviation, we will use always a positive number, not a positive number. We will always use the absolute number, and without considering the algebraic sign, that is plus or minus. So that's why if we calculate the mean deviation from the different set of samples, so again and again, so every time you get same result, so that means it doesn't differ from sample to sample and it has sampling stability. Clear? So now move on to the next slide. So here we can see some disadvantages of the mean deviation. So mean deviation is non-algebraic in nature, because we have already told we are taking only the we are taking only the absolute values without considering the algebraic sign. So that's why mean deviation is non algebraic in nature, and it is not capable of further algebraic treatment also. And now going to the second point, mean deviation is not a well defined measure, since mean deviation calculated from the different averages, that is mean or median, may not be the same. So this is not a well defined measure of dispersion, because always we calculate mean deviation from the from always mean or median. Okay, so we are calculating mean deviation from average, that is mean and median, and that's why it is not well defined absolute measures of dispersion. So that's why this is one of the disadvantage of the mean deviation. I think this is clear. So now move on to the next slide. So here we can see the another or most important measure of dispersion, measure of absolute dispersion, that is standard deviation. Okay, so standard deviation is the square root of the arithmetic average of the squares of the deviation measured from the arithmetic mean of the data. So we have already told standard deviation is the most commonly and widely used measure of dispersion. As noted earlier, it is a measure of average of deviation from the average. So the average chosen in the case is arithmetic mean. Okay, but since some of the deviation from the arithmetic mean is always zero, and it is one of the most important characteristics, summation of the, okay, 1 minute, x minus x bar is equals to 0. So this is one of the most important characteristics of the arithmetic mean or average. So that's why when we are calculating standard deviation, always we take the squares of this deviation. Okay, so now going to the main thing, what is the differences between the mean deviation and the standard deviation. So basically we have already told in the mean deviation we are taking only the absolute values of deviation. Okay, without considering any algebraic sign, that is plus and minus. Okay, but on the other hand, in the standard deviation we are taking the squares of the deviation. So that is the basic differences between the mean deviation and the standard deviation. So standard deviation is the square root of the arithmetic average of the squares of the deviation, which is measured from the arithmetic mean of the data. And the standard deviation is always important and the most popular measure of dispersion. We have already told that part. So, standard deviation is an important and the most popular measure of absolute measure of dispersion, most probably, and it was introduced by Carl Pearson. Okay, and that's why standard deviation is also known as root mean square deviation. I think this is clear. What do you mean by a standard deviation and all? Okay, and most importantly, one thing, standard deviation is generally denoted by the small Greek letter, that is sigma. Okay, so this is called the sigma, and this is the sign of standard deviation. So in my next session, we will discuss what is the calculation process of the mean deviation and the standard deviation with different types of example. So we are done for the today's session. So if you like my video, so please do not forget to like, share and comment, and please do some support and subscribe. I will come again with a new session. Till then, stay tuned. Happy learning. Thank you.